We're all seeing it, right? AI is moving at this breakneck pace, changing pretty much everything. But there's a flip side to this incredible story of progress, one that we don't talk about nearly enough, and that's the massive and growing environmental price tag.
So that's the big question we're diving into here. AI is getting smarter, it's getting faster, but what's it actually costing our planet? It's time to pull back the curtain and look at the real-world bill that's coming due for this digital revolution.
And this brings us to what you could call the paradox of speed. Think about it. The faster we push AI forward, the more physical stuff we have to build. Data centers, servers, you name it. But here's the crazy part. The faster we innovate, the quicker all that brand new, expensive hardware becomes obsolete and gets tossed out.
I mean, just look at how fast things have exploded. Back in 2019, GPT-2 was the big deal, with 1.5 billion parameters. Seemed like a lot, right? Well, fast forward a couple of years, and training a model like Bloom sucked up the same amount of energy as 30 US homes for a whole year. And then boom, 2023 rolls around, and GPT-4 hits the scene with an estimated 1.7 trillion parameters. Trillion. The jump is just mind-blowing.
Let's put a number on that leap. We're talking about an increase in complexity of more than 1,100 times in just 4 years. This isn't like upgrading your phone. No, this is a total paradigm shift. It means we need entirely new kinds of supercomputers just to stay in the game.
Okay, so what is driving this crazy, relentless cycle of building and then just junking everything? Well, it really boils down to 3 main forces that are creating this powerful engine of obsolescence. First up, it's the sheer size of these models. The jump from GPT-2 to GPT-4, that's not just a step up, it's like putting a skyscraper next to a 2-story house. This constant demand for bigger is better is the #1 reason that perfectly good hardware becomes practically useless, seemingly overnight.
And that directly feeds the second driver, a full-blown corporate hardware arms race. You've got the tech giants, Google, Microsoft, Meta, all locked in this massive battle for AI dominance. They're pouring billions into having the biggest, baddest models, and that means they need a never-ending supply of the latest and greatest chips, period.
Want a real-world example? Look at NVIDIA's A100 chip. In 2020, this thing was an absolute monster, the best of the best. But by 2023, just 3 years later, the new H100 chip made it obsolete for cutting-edge AI. And again, we're not talking about your old iPhone. This is like ripping the engine out of a multi-million-dollar data center and throwing it in the trash.
And the third driver? It's an old trick in the corporate playbook, planned obsolescence. Basically, manufacturers intentionally design products to have a short lifespan. A classic move is to just stop supporting the software, like Apple did with its Xserve servers, forcing you to upgrade. And boy, does it work! A whopping 60% of companies end up replacing their servers every 3 to 5 years, even though that hardware could easily last for 8 years or even longer.
So you can probably guess where this is going. All of this constant upgrading and trashing of hardware, it comes with a huge, and often invisible, environmental cost.
And to really get a grip on that cost, there's a key term you need to know: embodied carbon. Now, this isn't about the electricity the data center uses to run every day. Nope. This is all the carbon pollution created during the entire manufacturing process, mining the metals, making the concrete, shipping the parts, all of it, before a single switch is even flipped on.
And the scale here is, well, it's pretty shocking. Back in 2022, data centers accounted for about 1.5% of all global CO2 emissions. To put that in perspective, that's roughly the same carbon footprint as the entire global airline industry. So every time we junk a data center early, we're hitting the accelerator on those massive upfront emissions. And it's not just about carbon. This relentless demand for new gadgets puts an incredible strain on other resources too. Take lithium, it's in everything. Just to produce a single metric ton of it can take, get this, 2.2 million liters of water. That's a staggering amount, and it's often taken from places where water is already scarce, just wrecking local ecosystems.
So what happens to all this old hardware? It becomes part of a massive industrial-scale e-waste crisis. In 2023 alone, the world generated over 60 million metric tons of this junk, and the recycling rate? A pathetic 17.4%. You have to ask, why so low? Well, for complex things like servers, it can be up to 5 times more expensive to recycle them than to just landfill them.
And the really tragic part is that a lot of this toxic waste gets shipped off to developing countries, where it's often illegally burned, poisoning the air and the people who live there.
Okay, when you look at all these numbers, it's easy to feel like this cycle is just unstoppable. It feels pretty bleak. But that brings us to the most important question of all. Can we break it? Is there a better way to do this?
And the good news is, the answer is yes. There absolutely is. There are clear, practical steps we can take to build a much more sustainable AI. So let's get into what those look like.
It really comes down to a three-part plan. Step 1, start designing hardware for longevity. Build it to last. Step 2, optimize the software to be way more efficient. And Step 3, build what's called a circular economy, where we focus on reusing and recycling instead of just constantly taking and trashing.
And this isn't just some pie-in-the-sky idea. This stuff works in the real world. Take Google's modular server project. They designed servers where you can just swap out individual parts to upgrade them. The result? They doubled the lifespan of their servers and slashed their hardware waste by 45%. It's proof that this approach works.
The second piece of the puzzle is all about changing our thinking on the software side. We need to move away from bigger is better and embrace smarter is better. There are techniques, like one called Dilbert, that basically shrink these giant models down into smaller, more efficient versions without losing much accuracy. And doing that can slash the energy needed for training by as much as 40%.
And finally, that third step, building a real circular economy. What does that look like? It means creating actual markets for secondhand data center gear. It means using tech like blockchain to track materials so we can recycle them better. And it means passing laws like right to repair for big enterprise hardware that make companies support their products for a reasonable amount of time.
When you put all these solutions together, they all point to one big fundamental shift. We have to completely change how we define progress when it comes to AI.
So here's the change we need to see. For years, progress has been all about raw power. How accurate is it? How fast is it? How many parameters does it have? The new way of thinking says, hold on. Let's measure progress by its true cost. Let's look at CO2 per accuracy point. Let's look at watts per computation. Let's look at how recyclable the hardware is. That's real progress.
Because at the end of the day, the future of AI can't just be this brute force race to see who can build the biggest, most power-hungry model. It has to become a race to see who can build the smartest, most ecologically efficient one. That is the only way this is sustainable.
And that leaves us with one last big idea to chew on. What if we actually created an international AI sustainability index? Imagine a public leaderboard that didn't just rank AI models on how powerful they are, but on their true total cost to the planet. Now that could change the game.